Hi, I'm Thomas Digidiotis, and I'm going to present you my system for the bachelor thesis with subject automated machine learning. So as you can see here, this is the landing page of the system with the logo of Cyprus University of Technology and the main subject of this system. So we have four choices. The About Us is the sector that I'm saying that who I am, why I'm doing this system, for what purpose, and so on. Here it's also said before the landing page, which contains some text and some explanations about what is automated machine learning, what is the pipeline, what is the automation on these machine learning algorithms, what types of automations, and one motivative text about the user. So here on AutoML, we can choose from classifiers and regressions. If I want to classify my records, the system will go to find the best and the optimal model for our dataset, specific our dataset, and give it back to us. So I'm going to continue with classifiers and not with regressors. Here is the dataset that I'm going to use, and now I have to wait 2 or 3 minutes until all the calculations complete, and the system give me back the optimal model and the algorithm that fits better on my data, and that is going to give me more accurate classification data. So on this stage, the system is going to run our dataset on all these classification algorithms, take the one with the better score, and represent it to us to know which algorithm is it and what score it scores. So we're waiting until this stage complete. So as I said before, here the optimal model scored 90%, and now we can proceed with our dataset that I want to classify their records, the CSV file, or I can download the model as a Python code, or I can finish. So I'm going to continue with this file just to see that the system can see if we have errors on our values or missing values and so on, to prevent the user from giving wrong data and take back wrong answers. So here on our model, I have implemented for medical data 2 datasets. and three models: the neural networks, linear regressions, and k-nearest neighbor. We can proceed with neural network just to see what is going on. Here we can fill the form if we want only one record to classify, or we can choose a CSV file, and then with the submit button, the system will provide us with the appropriate information about the classification and so on. So the system is implemented in Django, which is a framework that you have the opportunity to run Python codes for backend in a web-based environment, which is the front end. In Django, we have MVT and not MVC, which is model view controller. We have model view template with the view. The view is play the role of controller, and the template plays the role of the view. Django is fast with its configurations. It provides a big amount of components, which is where it's available. We have the advantage of the security of the data, scalability with multiple users, and the main advantage, the functional advantage, is that we can have Python codes and scripts as the backend, and CSS, JavaScript, jQuery, HTML, and so on front end. So to install this Django framework, we need to set up firstly our Python, and then inside the Python, the Django framework will be stored. So we are going to download the Python from Python Software Foundation, and then go to cmd prompt to verify that we download the Python. So now we're going to the CMD to see all of these things. So here we are. To check that if we have downloaded the Python, we just say to the CMD Python version, and we got that our Python version is 3.0.5. Then we want to have the pipe, which if you have Python, it's easy to install it with Python pip download. And to verify that we have the pip, we do pip -version. So we have the pip 20.1.1. Then we have to set up our virtual environment and virtual wrapper. So we put this command pipe install virtual env wrapper win. Now because I have it downloaded from before, it's a new version I think. So yeah, I'm taking the upgrade of this virtual environment. Okay, now we have to make the virtual environment and put it a name. So mk to make something, mk virtual env, and then for example the text. oh, something went wrong. mk virtual env and then test. So you see that my virtual environment test already exists. And now we're going to install Django. So pip install Django. Again, I have it already installed, so I don't have to reinstall it. So now, if we are going and open a new CMD window, we have to go and enable again this virtual environment. So here we are, virtual and okay, it's already enabled. And now the only thing we have to do is to write the cmd command python manage.py run server. With this, we are taking on this HTTP request, we are taking our site, and if we put on our browser, we are going to our localhost and we have it set on. So now I'm in the Python 3.9.0 folder and I'm making a subfolder project to install all of my projects there. So now I'm going to make a folder to install my first app. So make dir my first app. Now I'm changing to this directory. And now I'm going to set up my first Django project. So the command is Django -admin start project. Now I'm giving a project name. Now the project is installed to my first app. And now we have to change our directory to project name, where inside here is the python manage.py file, which is the main controller of all of the features of the Django. And I'm doing python manage.py run server. And now I'm going to take a new URL for this site here. So as you can see, this is the first page of the Django, which we have to say that the install worked successfully and congratulations. Here we have some documentation, some tutorials, and the Django community for advices and so on. So now we can open the Visual Studio Codes. So now I open my folder with Visual Studio Codes. So we can see here my first app, the project name. Again, the project name. This is the main file, manage.py, which is the handler. Here we have an SQLite database to install if I want. And here is my main project on the project name here. So now we have many Python files, which I'm going to explain now. So here on the settings, we have many things to put on. So firstly, we are going to see this debug, which if we are going to push our application for commercial use and sell it, for example, we have to put here the false, because now as we are trying to implement more and more feature on our application, if we got an exception, this true that debug equals to true here is going to prompt us on the main screen of the site the error that we have allowed hosts. Here we can put the star, so all of the hosts can access our site. And then we have the installed apps. Here is the place that we can go and say to Django if we want to install a database, for example, and in general whatever we want. Then it's the place for the middlewares, and we are not going to see anything on this. Again, here are the configurations of the databases. And this is the most important thing in Django. The external files as CSS, JavaScript, pictures, and so on, we have to load them to a folder as static or whatever we want in whatever folder we want, and then we can call them from the main HTML file of the Django with a specific command. So now here we have the URL, which we say that if I take this path of URL, bring me to this exactly folder, for example, admin sites URL. So and then the system is going to search the paths here of the URL and the page that we want to see from this request. So now we can go again here on the project name and put the command python manage.py startup, and I give an app name. This is going to make me, as you can see here, a new application, because one project can have many applications, and that's the correct. For example, if I want to do a specific task, for example, insert some data, I'm going to use a new application. And if, for example, I want to present some other data, I'm going to use another app inside this project. And now you can see that we have the views, we have again the URL. Where is the URL? We don't have the URL, but we have to implement it, urls.py, and then go to this main file, paste this one here. So the main difference of these two URLs files is that in our app we probably have many URL requests for many features. So inside here we say that if we are on this application, we say that for this path I'm going to load this site. So firstly, the application goes to the general URL.py of the whole project, see if the request match in anything of these paths here, and send it to the URL of the specific and the URL file of the specific application. For example, here, to find the appropriate page to be loaded. Now we're going to set up a small application like the Hello World as all of the online guidance. So here we have the views. Inside here we can have many Python codes, and from URLs we are going to use these views here. So that's why before I said that controller is a view in Django, because with the view we have all of the functionality of the project. So if a URL we have bring us on a specific view, it means that the system is going to execute the Python code inside the view, for example a function, make some tasks, and then if we want we can render back a new page, or we can stay in the same page, it doesn't matter. So now we're going to set up the first small hello world, our first application. So here on URLs we put path nothing. So this is for our first page, and then we say to the Django go to views.home and find, and the name of the code that you're going to execute is home. Now we're going to views, and I'm going to implement this function def home, which we have to say have the same name as this one. We are taking a request, and what I want to do, I want to return the HTTP response hello world. And now to work with this HTTP response, I have to import from Django.http import HTTP response. And now to find this URL here, the whole project. I'm going to the URLs py of the main project and include a path that says that if I'm take this URL, the empty, I'm going to include the app name, which is app name dot URLs. And now again I'm going to import the include from Django URLs. Now this is going to work. So if I go here again, I'm going to say python manage.py run server. I'm getting an error, which is the view. So I think that here we have to just a moment. It's views. Yep. Now I'm going to run again this Python, but what I haven't saved it. I'm taking the same error, which is from project name, app name, urls.py. So from here, I can determine the y, because we don't need it's views.home, and here we have home, yeah. So yeah, we have to import this views now. So I forgot it. From the project, import views. That's why Python didn't work. And now you see when I put it, automatically I take the correct URL. Okay, now we click the hello world. So now we're going to see each folder and each file of the system of my bachelor thesis, so you can understand better some things. So here it's our templates. You can see that it's HTML files. All of the files is HTML, and the only thing that is not so familiar with you is this static here with these 4 symbols. This is that I said before that this style sheet, this CSS, it's going to find it on CSS Bootstrap on CSS folder, and it's the bootstrap me.css, which this CSS folder which contains this file, it's inside static. So go to find the static, load it, and go to find this URL inside the static folder. As you can see, it's all of this familiar with you as an HTML file. Here we have this static CSS and JS that we need. So here we have the CSS folder with all CSS that I had and some pictures, the JS, JavaScript, and here is the dataset that we have and some pictures. So from here it's going to take all of these files that I include on my HTML file. Now we have the general manage.py as always. We have the database SQLite, which I didn't use it, and the file to be exported, which we are going to see after. Now this is the main folder of the project. So here you can see that in settings I have this false because it's I debugged the system many times and I didn't find any other fault or exceptions. Allowed host everything here, and the main thing is here, the static URL, which is where to find this folder here. It's /static/. So the static files dirs directories, so where to find all this data inside it. We are going to the os path.join the base dir, where is the static slash, and then the static css.js, which is our folder, and the static root for all of this is the base dir again, this one, and assets. So inside URLs you can see that if I take the /home, I'm going to include first page URLs. On the results, the same, and so on. So if we go on this folder here, my main application, on URLs, you can see that with the path home, it goes to the views homepage, name homepage, model, views model, and so on. So now, if for example something comes to and it's slash on the URL we have /home, the system goes to this big folder with many Python codes, find the appropriate function, and make some functional things, and then it returns to the main page. So here, as you can see, I used many TensorFlow imports, for example the dense dropout batch normalization, the sequential, which contains the mathematical expressions to build my model. Another extension that I used to do the automated machine learning is the teapot. Again, the teapot is one extension of Python and is implemented a teapot classifier and a teapot regressor. As you can see here, we have verbosity where it's how dense and how many connections will make the model will make, how many generations will learn, and if I don't have any improvements as the generations run, I'm going to stop this this workflow because it doesn't matter to be executed until the end if I don't have any improvements on the performance on my model. So here you can see an error 4.4 view, which you can see it in this is the main function that if something went wrong or I got an exception, I will return this page to inform the user. And this instruction, we can find it on settings. Here you can see that there is a folder of migrations, which we migrate this static CSS and JSS folder. If we don't make migration, the system would not find the appropriate files that we want to attach. And here again, the assets contains all of these files that we want. This is difficult configurations that Django needs to work, and it's the only disadvantage of the whole system. So now we can see the functional part of my system. Here, for example, on the render, we put a request, we put what to render to the user, and we can attach variables on it. So with the neural word, I'm going to take the prediction for /neural, which is for example a list of values. And this neural, if I go to results.html on my templates, I'm going to see that I can put these two symbols, and inside these symbols I'm putting the name that I gave to this variable, the neural, for example, and I'm taking here the variable printed. So here you can see some instructions of NumPy, which help me to manage with the arrays of the data. Here we have some exceptions, and if we throw these exceptions, we are going again to the exceptions.html, and I'm going to use these exceptions to define what exactly was the exception. Okay, this these methods, these functions here are just to render me to a new page, for example, from the navigation bar. All of the navigation options that I have, it's from the renders will be from here. So if I have a form on this HTML form, for example, on this HTML file, I can take them with request.post and the name of the, for example, dataset, and the name of the input that I put when I generate it. And if I put a get and not post method here, I'm going to put get in capital letters like post. Here are the point that I use pandas and TensorFlow together. So with pandas I read the CSV file which is on the static place of the system, and here you can see that I put many layers to predict something or classify it. I think here I have implemented the neural network, my first neural network, and this all mathematics behind these all instructions are in the extension of TensorFlow. So here are all of my functionality. With this function here, I'm going to return an HTTP response. So I will open this file that I mentioned before to export, to read and write. I'm going to read it, then determine that the context is a text, and then the response is to attach this file with the name model and return the response. From the web page is the point that I want to download the optimized model that my system found, and it opens on Python code. Here is the results of the teapot. Yeah, that's all functionality. Here is the file system storage that I forgot to mention before. I put I'm calling the file system storage class, take the object of fs, and then I'm saying to the system that I'm going to save this name, which is the name of the folder, and this file, which is the object which contains the file. And with this, I'm saving the CSV file that I import in my system to take the data and train my algorithm. Then, to make the system better, the system's performance better, I'm going to delete this file after the use that I did. So now we are going to see a small presentation about automated machine learning, how machine learning changed from automated machine learning, and what steps we are automating so we get more profit. So machine learning is a study of computer algorithms that automatically improve with the data flowing inside them and build model based on initial data so that we can use them to predict prices and make decisions. We have three categories: the supervised learning, the unsupervised learning, and the reinforcement learning. Each category has its own characteristics and its own usage. For example, one of the categories is when we have the labels of the attributes that we have, and then we are trying to predict for new data their label. Another category is the category that help us to see patterns and discover patterns inside our data. And the other class category is the category that we don't have the labels, and from the attributes we're trying to find them. So what's a process of machine learning? So firstly, we have to collect our data. For example, if I'm trying to categorize picture of dogs and cats and the system has to say me what species of animal it is, I have to collect my data, pictures of dogs and cats, so I can train the algorithm. So I have to collect appropriate data that answer my question and solve my problem. Then this data I have to clean them because, for example, I might have empty values or missing values or incorrect values. So I have to take the decision if I'm going to delete the rows of the of the wrong data or don't, or if I won't take into consideration the specific cells with wrong data. On the data visualization, we're able to see and discover new patterns of our data, and it's very important to see if our data is correct and if it's answers our question and solves our problem. Then I'm going to the algorithm training, which is a very time consuming process because I have to train my algorithm and then test it with the testing dataset and to find the better model for our algorithm, this with the higher performance. We have to make changes continuously and test it continuously about its performance. And then I have to evaluate this result if it's the maximum performance that I can take from an algorithm, from a model. So I'm going to construct and continue with this algorithm. So automated machine learning has the same purpose as machine learning, but the only difference is that the process on automated machine learning is done automatically. In automated machine learning, the steps that is being automated is data cleaning. For example, we can say to the system that I want to skip and delete the missing values or the wrong data, or I can say, okay, take the correct attributes of the row and put something like an average of other values from the wrong or missing value attribute on this row. Then the process to find the optimized model, it's the most time consuming step, so we have to focus on it, and that's why we are trying to automate machine learning, because this step is the biggest and the high risk to do mistakes. So with an automation, we give the dataset and we tell to the system that we have to take the maximum performance of algorithm on this dataset, and the system goes and run all of the algorithms based on our requirements and find the appropriate that fits our requirements. Then the evaluation is being automated, and we can predict many records and not one by one with this automated machine learning system. So here we are seeing a small picture about how this automated machine learning model is building up during the time. So we have here our dataset. Then with the transformation function, we insert them into the model building. Here we have the model configs. For example, if I want to do regression or I want to classify the data, then the system constructs multiple models. For example, models for neural networks, models for SVMs, support vector machines, and all the appropriate algorithms and models to do a classification if that's one of my requirements. Then the dataset runs on each model. Then the model is being tested for the performance. And then from the list of the performances, I'm taking the maximum one, and I give back to the user the code in Python language of the model and the algorithm that fits its requirements and has the better performance. So the whole mean of this presentation is to show that if we are doing alone some steps in machine learning, it's very time consuming and high risk because they are large, we are humans, and we are making mistakes. So if we are making a mistake inside this here section, the model building, for example, then all of the process will be wrong. So we need to be very focused on what we are doing. And this problem, automated machine learning came to solve. So with these automated machine learning models, we can automate all of the process, so the user has only to give their dataset and the system makes them all. And then the user has to give another dataset to classify or predict a value. and the system will predict it based on the model that it has, and it's the best on its dataset. So thank you very much. I hope that I helped a lot to understand what is automated machine learning, what's the difference from machine learning, and why it's important. And I hope that the small and no long sessions on Python Django might help